Astronomers just detected what may be the most powerful flash of light ever seen. The so-called gamma-ray burst, the most energetic type of electromagnetic explosion known to exist in the universe. But the question is, what are these gamma-ray bursts? And what phenomenon creates these mighty cosmic explosions? How do gamma-ray bursts produce such high energy and luminosity? Let's answer these crucial questions. A gamma-ray burst, or a GRB, is an intense blast of gamma rays. It typically lasts a fraction of a second, and within that duration, it releases as much energy as the entire Sun would in its 12 billion-year lifespan. But what is the source of this tremendous energy? Let's look at gamma rays to get a better understanding. Gamma rays are at the highest end of the electromagnetic spectrum in terms of frequency and energy, and they have the shortest wavelengths. A gamma-ray photon has 1 million to 1 trillion times the energy of a photon of visible light. These photons are packed with so much energy that they are a form of ionizing radiation, which means they can strip an atom of its electrons. So, they can cause ionizations that can damage our tissues and the DNA. But, on Earth, the ozone layer protects us from these radiations. It filters them before they can harm us. Now, the query is, how were gamma-ray bursts initially found? The first GRB was detected by accident in 1967 by the Vela satellites, which were a network of satellites that the United States launched to detect nuclear explosions in space. The Vela satellites detected a burst of gamma radiation that lasted for about 2 seconds, and it was initially thought to be a nuclear explosion. It wasn't until much later that scientists realized that the burst of gamma radiation was actually a GRB. Since the first gamma-ray burst was detected in 1967, a large number of GRBs have been detected by satellites and ground-based observatories. According to NASA's Fermi Gamma-Ray Space Telescope, a satellite launched in 2008 to study high-energy gamma radiation from the universe, more than 3,000 GRBs have been detected as of 2021. The Fermi Gamma-Ray Space Telescope has detected more than 2,000 GRBs, while other instruments and observatories have detected the rest. There are two main types of gamma-ray bursts, long GRBs and short GRBs. The main difference between the two types is the duration of the burst. Long GRBs typically last for more than 2 seconds, while short GRBs typically last for less than 2 seconds. Long GRBs are thought to be produced by the collapse of a massive star and the subsequent formation of a black hole. The energy of a long GRB is released in a burst of gamma radiation that lasts for several seconds to several minutes. Long GRBs are relatively rare and typically found in distant galaxies. On the other hand, short GRBs are thought to be produced by the merger of two neutron stars, or the collision of a neutron star with a black hole. The energy of a short GRB is released in a burst of gamma radiation that lasts for a fraction of a second. Short GRBs are more common than long GRBs and are found in a wide range of environments, including nearby and distant galaxies. If the narrow beam of a GRB were to point directly toward the Earth, it would be detected by one or more of these satellites. However, it's important to note that the likelihood of a GRB occurring close enough to the Earth to cause harm is very low, even if the beam points directly towards us. This is because the energy of a GRB is spread over a large area, and the amount of energy that reaches the Earth would be relatively small. The recent record-breaking supernova is dubbed GRB 221009A, the first gamma-ray burst observed on October 9. The Fermi Gamma-Ray Telescope observed the initial flash in space. The second burst of gamma rays was caught by the Swift Observatory an hour later. Swift immediately sent an automated alert to astronomers worldwide, who responded by pointing their telescopes toward the burst. This was an unusually long gamma-ray burst, hinting at the tremendous energy it had at its disposal. GRB 221009A has attracted the attention of scientists for several reasons. Firstly, it flared up at a distance of 1.9 billion light-years from Earth, are relatively small by the standards of such events. Secondly, GRB 221009A surprised scientists with the amount of released energy. It became one of the brightest bursts in the gamma-ray range in the entire history of observations. In the X-ray range, this GRB shone several hundred times brighter than the brightest of the previously observed similar sources. Its source was in the constellation of Sagitta. According to astronomers, the gamma-ray burst was generated by the collapse of a supermassive star, which led to the birth of a black hole. Based on the amount of energy released and the burst duration, astronomers estimate that the dying star must have been 30 times more massive than the Sun. This GRB is an exciting discovery for astrophysicists studying high-energy cosmic phenomena. It's so bright it will take months for it to become too faint to see with telescopes, meaning astronomers have time to study it. Astronomers still need to figure out why this particular GRB is so bright. But they believe a multi-wavelength analysis will indeed decipher this mystery. GRBs are important because they provide a unique opportunity to study some of the most extreme and energetic phenomena in the universe. They are also important because they can be used to study the early universe, since they are visible from great distances and can be used as beacons to probe the interstellar and intergalactic medium. If you like this video, hit the like button and subscribe to my channel. Thanks for watching.